This short video is a glimpse of the Norwegian Continental Shelf Pipette project that Kjetil Johannessen and Petrostreamz co-workers are building as part of Kjetil's master's thesis and Petrostreamz' development of an open platform for utilizing the fantastic data and information made available by the NPD. The Norwegian Petroleum Directorate maintains a website called Fact Pages. The NPD Fact Pages contains information regarding the petroleum activities on the Norwegian Continental Shelf. The Fact Pages is synchronized with the NPD's databases on a daily basis. From the Fact Pages, we can find information about all the fields, the remaining reserve estimates, historical production data, facilities, wells, and a lot more information. We download all this information and present it in a graphical and intuitive way. This allows us to make assessments on a large scale. The Pipette Integrated Asset Modeling tool is used for this task. We build this NCS project starting with a simple template. The template is applied to every field in the same way, being populated with appropriate field-specific information read directly from the NPD public database. The brown boxes are called composites and represent virtual folders. They can serve several different purposes. The composite in the top left corner will connect to the NPD fact pages and download or update new data as it becomes available. Let's enter a composite and take a look. The blue rounded rectangles are called resources and represent files located on the hard disk. The green ellipses represent a process, which can be any program or application run from your computer. In this case, the URL files are simple text files containing a URL address that specifies where we can download the files we're interested in. The download process launches a console application called curl. Curl will use the URL from the input file to download the data, stored on the output file. Then, the output file is stored on the hard drive, and the output resource is associated to this file. Now let's execute this composite. Comma-separated files are not very convenient to work with, so we'll convert it to a file format called streams. This will allow us to work with the information stored in the files in a convenient and efficient way. We'll discover how later. Let's now open a streams file and take a look. So, now that we've accessed and structured the information, let's take a look at what we have. Discoveries, wells, forecasted reserves, historical production, license information, and data about facilities. We also fetch historical oil and gas prices from other resources to use for economic assessment. So now let's take a look at the Norwegian oil and gas production history. On the left, oil production history, and on the right, gas production history with seasonal variation. Now we've seen and have access to historical production data from every field on a monthly basis. What can we do with this data other than just looking at it? As part of Kjetil's master's thesis research, he is using the Fetkovich-based decline curve models to forecast oil and gas production by field to generate a Norwegian Continental Shelf production forecast. Proper decline curve forecasting requires the current initial rate, remaining reserves estimate, and decline character, expressed as the ARPS exponent B. The NPD database provides initial rate and remaining reserves by field. The ARPS exponent ranges from 0 to 0.9 and should be history matched to declining production data. Let's take a look at how this works for Oskar field. To do decline curve analysis, we simply execute the program, and the calculations are done in a matter of seconds. We can go into the plot composite to look at the forecast oil and gas production rate. As we can see in this plot, we have historical oil production data in green and the decline curve forecast shown in dashed lines. In order to generate the model for the entire Norwegian continental shelf, we have to launch a special process which is located here. This will create and populate a composite for all the fields specified by the input data. This will take a few minutes, so I'm just going to open a model that's already been built. As you can see, this is the same model, but we now have a composite for each and every field. The field production streams are being gathered in manifolds, and now we can look at the total historical and forecast production for the entire Norwegian continental shelf. The NCS forecasted oil production looks much like Hubert's idealized peak curve. A similar production forecast using decline curve methods is not applicable for fields that have not yet gone on decline, such as Troll and Ormen. The NPD-based Norwegian continental shelf Pipet project can be used to assess two important game changers: large new discoveries like Sverdrup and successful EOR projects like Ekofisk. How will Sverdrup influence the future NCS oil production forecast? Based on reserve estimates and initial production rates for comparable fields, we can estimate how Sverdrup production will develop over time. Let's now connect Sverdrup to the NCS production forecast manifold in our Pipet project. Then go into the combined NCS plot composite. And as you can see, we get a significant increase in total production when Sverdrup comes online. Let's investigate how an EOR operation can be modeled. Before we close this plot, we can make a mental note of the current rate of the total NCS predicted production. It is currently predicting an oil production of approximately 7.5 million standard cubic meters per month. As we don't want Sverdrup's oil production influencing our EOR analysis, we'll disconnect it from the project temporarily. A suitable candidate for our investigation of EOR can be, for example, the Troll field. And further into the oil decline curve analysis composite. First, we have to disable the automatic generation of the decliner driver file, as we will be overriding the information. Then we access the Troll data file via an interface called links. This allows us to directly view and modify a text file without actually having to open it in an editor. To simulate an EOR procedure, we will increase the Troll initial reserves by a factor of 1.5. Indicating that we'll produce an additional 50% of the historically produced production. This should in turn result in a higher oil production rate today at the initiation of the EOR project, so we double that value. And we move back to the Troll top level and run the model. Now that the model is updated, we can go back to the NCS total prediction plot and investigate. As a result of a successful EOR project, the total oil production rate has increased from 7.5 to an estimated 8 million standard cubic meters per day, and the Norwegian continental shelf oil rate decline has been reduced accordingly. An important consideration for studying EOR impact on long-term NCS oil production forecasting requires that the fields with EOR potential, for example those identified in the OHM report, be assessed in terms of EOR peak rate, EOR incremental reserves, and time of EOR implementation. With these three parameters, decline curve methods allow sensitivity and optimization studies of the Norwegian continental shelf. What we've seen now are just examples of how the NPD Norwegian Continental Shelf Pipette project can be used. Other applications are only limited by your imagination and needs. We foresee that operators may want to do NCS-based assessments of assets where they are partners or want to become partners. Another application would be geographically defined assessments, for example north of the 62nd parallel. We hope that the industrial and government organizations can help guide the further development of our work with the NPD database. Thank you.